about how much of how many smaller cubic units will fit inside a three-dimensional figure. That's volume. But we're now going to surface area. So we're going back to area. So we're going back to square units. And this is what surface area is, because it does not involve one flat surface. Surface area is the sum of the areas of all the faces of a three-dimensional figure. So none of this is new material. You all know how to find the area of a two-dimensional shape. It's length times width, or base times height, with parallelograms. So what surface area is simply the sum of all those areas added together. So this example, can everybody see this box right here? If I'm going to find the surface area of this rectangular prism, I'm going to find the area of this face in square units, and the area of that face, and the area of that face, this face, this face. In other words, all 6 faces. So far, everyone on board? Okay. So I have graph paper, or square units here. And so this face right here, if you count across and you count up, is a 10 by 12 face. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 10. So how many square units? Oh, Carter, very good. I'm seeing, yes, 120. Now, this is a rectangular prism. What do you know about the opposite? This is the top. What do we know about the bottom? This is a rectangular prism, and the top is 120 square units. So what would we know about the bottom? Are you seeing those same? It's the same. That's exactly right. It can't be a rectangular prism unless opposite faces are equal. So that means that we have another 120 square unit face. Everybody on board with that? Okay, now we're going to look at the side. And we're going to have to pretend that there's a little overlap here. We're going to just pretend that they're perfect squares. And I have here 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is the area of this face? Okay, I'm seeing a lot of 48s. So if this is 48, what do we know about this face? Okay, it's also 48. Okay, one more side, so to speak, and it's this one. And if this is 1, 2, 3, 4, and this is 10, what is the area of this face? Okay, 40. And what do we know about the opposite face? Same, same, same. Okay, so who can come up with a statement about how I would find the surface area of this entire prism? Who can write it out? Or I want everybody to try to write it out. What would the steps be? Mrs. Wharton and Ms. Griffin, are you seeing, you find the top and side areas and then add them? Find the top and side units, multiply by 2, then add. Okay, I've only seen, I want to move this along. You could do one face at a time. How many faces, if you did one face at a time, how many faces would you be adding once you found the areas? How many? If you did one face at a time and you found the area of the surface area of the entire prism, 4, how many would you be adding? I'm seeing 4, 6 faces. Yeah, you do this face, plus 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 this face. But Alex said, find the top and then multiply it by 2. Find the side and multiply it by 2. Find the other side and multiply it by 2. That might make it faster. So your units are square units because it's area, but it's adding the area of 6 different faces together. And I have one more example. This one does not have squares because not all your problems will have squares. But I have a 4 by 4, and then I have 2 by 4, 2 by 4, 2 by 4, and 2 by 4. So type in the surface area of this figure. 4 by 4, 4 by 4, 2 by 4, 2 by 4, 2 by 4, and 2 by 4. Okay, I'm seeing a lot of 48s. I am seeing some 64s. Okay, this is 4 by 4, and this is 4 by 4. So what would the surface area, or what would the area of those 2 faces be? Okay, now this is a 2 by 4. So is this, so is this, and so is that. So what would the area of all 4 of these faces be combined? So now I would add those, and what would the surface area be of the entire prism? Okay. 64 square units. And one thing that this prism has that the other one didn't is that instead of having this face and this face matching and these 2 matching and these 2, all 4 faces of the sides were the same. So you could even 4 times 4 times 2 and 2 times 4 times 4 because they are all equal or congruent.